Okay, just try whether it's working. Could you hear me? Okay, thank you. So, thank you for the introduction. I'm Melinda Tóth, coming from Hungary. I'm a researcher at ELTE-Soft University and working with RefactorErl. What you may heard the name of RefactorErl. Maybe some of you heard some talk before about RefactorErl as well. Today, I would like to present the main code comprehension functionalities of the tool, presenting you some general ideas about why we are doing it, why we are thinking that a tool like that is useful, and at the end, or maybe in the middle, we will see, I want to show you a short demo as well, just to present that this is working, and if you want, you can try it at home as well. So you may ask that why RefactorErl? I guess that your first idea is that this is a refactoring tool, because refactor is the first part of the name of the tool. Yes, it is a refactoring tool as well, but not just a refactoring tool. This is also a code comprehension tool. And nowadays, the main focus in the development of the tool is try to support everyday software maintenance and code comprehension tasks. So you have probably a huge amount of Erlang source code. Some part of the code may written by you long years ago or long time ago, and some of them may written not by you but some other team members. And in a case like that, you just need sometimes to figure out that what that certain code part is doing. And this is the point where we hope that RefactorErl can help you. So you will see at the end of the presentation. So what we have is that we support different tool chain. We give a tool chain in RefactorErl that has different functionalities like code browsing and querying about different semantic information of the source code, checking the complexity. You can check the complexity of your source code, try to investigate, we try to help in bug finding and bug fixing as well. Try to draw the dependencies among the source code. So once you wanted to understand a source code or a software, the source code of a software, you may be interested that what code part depends on another part. So this is what we try to do. So basically focusing on grokking. I don't know whether I have that strange letters, or I do not know what instead of case. So who we are, started as a refactoring project, but now focusing on code comprehension. Basically, it's an academic project. So this tool developed by several university students, bachelor and master students, and some researchers at the university. So we try to bring among the different functionalities deep semantic analysis, so not just analyzing the code on token level and do something like a plain text search. So we really wanted to add some semantic information about the source code as much as we can find in it. So sometimes doing a static analysis in a dynamic language like Erlang is not really straightforward, but we try to gather all of the information that is possible together from the source code. And we try to add it and present it somehow to the developers. This tool is open source, so if you want, you can just download and try it. I wanted to highlight three main parts of the tool. The first one is the code comprehension. That is what I will demonstrate you in the demo as well. The other part is obviously the refactoring part. And when I'm talking about refactoring, I'm talking about different aspects of refactoring. So at first, you have the basic refactorings, like renaming or introducing some variable, eliminating some constructs. So just the basic steps, which usually change only a small part of the code or may have some effect on other parts, but usually the change itself is not so huge. We have refactorings to support the introduction of parallel constructs in the code as well, but this is also something that can be considered as a local transformation. And under refactoring, I mean also application restructuring or software restructuring. When you have a huge application or an Erlang software, and really it's really hard to see what are the dependencies in it, and you wanted to split it into, for example, several applications, then we have a component that's called clustering, basically to have the source code and try to split it to smaller components. It can be done on function level, so splitting the set of function to smaller set of functions, or do it in a module level. So having a big application and partition it to smaller applications, for example. And what we can do is at first try to calculate the optimal, or in some way an optimal partition, and also supported by refactoring to apply these kinds of restructuring. I do not really say that it's really a refactoring. It can be a kind of software restructuring. And the third part is to providing some metrics to give a kind of description of your source code, about its complexity, about its quality. It's not an obvious task, so we have defined several metrics, and usually it depends on the project what is considered to be complex and what not. Because when I'm telling you that the length of the recursive chains should not be longer than 5 or 2 or something like that, then you may say that, okay, I can understand if it has length 10 as well. So it depends on the developer and the project that what are the rules. It can be considered as a kind of design rule set. So basically these metrics usually are just numbers, and you have to somehow build or configure it to your own environment, that what you consider complex and what not. So what we think is that a tool like that may help you to understand this source code, help you to find sometimes some bugs. So you see the magic bad match in the source code or function close or something. You have a value and you do not know where is that value is coming from, and you just point that code for RefactorErl, code part for RefactorErl, and we try to figure out, of course, driven by the developer with some queries, and try to help to find the corresponding source code parts. It's good for newcomers as well. So if you have a product that you are developing and you just want to hire some new developers, and this usually the new developers spending hours, days, weeks on just browsing the source code and try to understand what's in it or what are the dependencies, and a tool like that we think may happen in it as well. So just to mention some features of the tool. So how the tool is working. Basically, we have an environment. So we are taking that we call a static analyzer framework, and asynchronous static analyzer framework, which takes the Erlang source code and of course parse it and creates a syntax tree and that kind of usual way of static analysis. But after it makes a step forward. So usually when you are using Xref or CTEX or some tools that try to identify some entities or some references, cross-references in the source code, it usually does it on the string level, so in the text or some tokenized form of the text. But what we are doing is that we try to identify so-called semantic entities in the source code. So once we find a record definition, we will exactly mark it that this is a record. It has a name, it's located here, so it belongs to some files. And whenever we find a reference to a record, we try to identify that which definition it belongs to. So whenever next time you will look for certain references, certain kinds of record updates or something, and you just name that I want the references for this record, we can exactly find only that one that's the real reference. So if you do it with a plain text search and you just try to find the references of a state record, then you will have it several places in the source code. But if you try to say something that the state record that was defined on some certain modules in the code, then you can't really filter it based on a token-based or some kind of search. So we try to, during the analysis, we try to link together those code parts that may be at different point of the source code in different modules, different files, but somehow belongs together. That same stands for function calls. So whenever we find, of course, a reference to a function, we try to connect it with its definition. We do it in a dynamic level as well. So when we see an MFA or or an apply call, we try to analyze that which function it may refer and connect it. And next time when you are asking that where are the references to this function, then we will point you the possible dynamic references as well and not just the static ones. And as well everywhere that it may occur. So we have our compile time analysis try to be as broad as possible, try to covering the analysis of different entities, functions, variables, record, modules, so some entities of the source code, we call it semantic entities, and perform some initial analysis on them. So for example, the scoping of the variable, static and dynamic function call analysis, and some more advanced stuff, for example, data flow analysis, which means that whenever we see a variable or something in the source code, we are able to calculate that what are the possible values. Of course, it will be a static analysis, so we do not know anything about the dynamic values that may come from the Erlang VM. But anyway, if it goes through, it's an interprocedural analysis, so we are trapping the control flow and the execution and try to calculate all the possible values. I've already mentioned dynamic call analysis. Just to show you some features of the tool, one of them that I wanted to mention is the semantic queries. You may ask that whether it's different from Xref. Yes, it's different because you may ask deep semantic information. So not just about function level, but also about records or macros. So you can build your own queries. Of course, we have some built-in queries for often used queries like where is the definition of a record or something. But you can build your own query, and if you are an advanced RefactorErl user, then you can build really cool queries that gives you lots of information about the precise information about the source code. I've mentioned the software complexity metrics, but we have, for example, deprecated code analysis as well. So you can search for different deprecates, and if you want, you can eliminate them as well. And just marked the dependence analysis, since this is something that also can be useful, but for huge code bases, it can result a huge graph, so sometimes it's better to filter it out. You can freely use RefactorErl on different environments, so you can just install it. Basically, the very core functionality of RefactorErl is working if you have an Erlang. If you want some advanced stuff or the whole functionality, then you need some additional software or dependencies as well. But basically, an Erlang is enough. For example, if you want to draw a dependence graph, then you need a graphist tool just to calculate the positions. So we have some external dependencies, but basically it can be installed to any environment and try to use it. The main, so if you wanted to use the tool in a team environment, it's usually fine if you just have an installed server, for example, where you install RefactorErl and the developers can join to that server, simply log into the RefactorErl environment through a web browser, and that's enough. And the basic functionality can be reached from there. But if you want, we have several user interfaces. So if you are an Emacs user, you can integrate RefactorErl as an Emacs plugin. We have a VI plugin as well, a console interface. So under console, we mean several things. So we have an Erlang shell interface, so typing Erlang functions and it prints you out some results, and we call it interactive Erlang shell interface. We have a scriptable one, so if you prefer to script, then we have a scriptable one. And we have a console interface, a command line interface for Linux users as well. And the web interface I've already mentioned, and all of them can be connected to the same server. So you just install RefactorErl to your machine, start it in an Erlang shell, and then you can, for example, manage your files from the shell interface, but use Emacs for refactoring and the web for browsing the source code, so you can combine it. It's easy. And we have some desktop GUIs as well, based on WX, and we have a Qt-based one as well. But this is just a local copy of the web interface, so you can basically just have a browser and have everything that's every functionality there. So just to mention that you can try it. It's an academic project, so it's not really a product that you buy and it's 100% perfect. So it's an academic project, but it's already used by the industry as well. So there were several projects who tried it, and it's working. It's able to handle millions of lines of code. Obviously, analyzing a huge code base, because of this precise analysis I've mentioned, takes time. But I must mention that you have to do it only once. So our analysis is an incremental analysis. So once you've analyzed your source code, we store everything in a database. And when you change the code, then you just say database synchronization, or say that analyze it. And we will automatically detect only the changes and analyze just the relevant part. So just to give you an example how long it takes, for 1.2 million lines of code, it took around 5 to 6 hours to analyze it initially. But when you are just updating the code, so changing 1 or 2% of the code, or maybe less, with one commit, then to analyze it, it's just a few minutes or even less than a minute. Okay, so you just have to wait once just press the button at the evening and you will have the database ready by the morning. Okay, and the incremental update is usually really fast. Mainly the functionality that was used by the industry is the code comprehension and the software restructuring. Neither the refactoring, neither other small functionalities were not tested by the industry, but you can do it if you want. So, as I said, it's open source, it has a wiki page, you can try to use it. And let me give you just a short demo that how it looks like, because I've told you queries and that kind of stuff, just to show. And then at the end, after the demo, I would like to show you some more functionalities as well. Sorry. So let me go back to the basic interface I've mentioned. So this is an already started RefactorErl instance, which is just bin/refer, and it started after the installation. So basically, I've already analyzed Nigia from OTP. This is the source code of the Nigia. And you can see that if I type ls, it just simply print the content of the database. And now you can see that I have around 20 or something, 25 files loaded to the RefactorErl database. And if you like, just type in Erlang function calls, you can just simply type, for example, a queue for querying. There is a help functionality, so if you want to check that how to build a query, you can see. Of course, the semantic entities and the real queries are not listed here. You should check the wiki page if you are interested in. But if I'm just saying that I wanted to check all of the functions, what I have in the source code, and have a list of it, then you just type mod.funs, which is a kind of XPath style or something. So you have selectors and build queries based on these selectors, and you can optionally filter it. So if you wanted to see only the function that has a name, parse term, then you have it. Obviously, this is not what you wanted to see. For example, you can check where these functions, what are the functions that call in this parse term. This is from another library, so I'm interested in that where is it called. Then you can see that it's called in the Nigia text return from state function. Okay? Stream, sorry. And you can build queries like that. Just typing, and you have some result. If you wanted to work further with the result, you can use the scriptable interface of RefactorErl, or you can just print it into a file and having the line numbers with the result as well, and you can script it and do anything what you want. Let me show you the web interface and possibly the same queries on the web interface. So on the web interface, you can type the same queries. So here, the same what I've done before. It has a kind of auto-completion, so it's a bit better than typing it in the Erlang shell, because it's it at least offers you the possible selectors that you can use. So I can type mod.funs, and the result possibly, I'm just showing the old result, is the same as I had before. You can't compare, but it's a bit easier to handle, because if you have a result, you just click on the result and it will show you the source code immediately. So it's a bit easier than to do the same from the Erlang shell, because then you need a separate editor or something and to check the body of the function. But here just you press a button and everything is there. let me show you a query that is more than just to have function calls. For example, one related to records. Obviously, I can list the records. This is something that's not so difficult. So I can type mods.records, and that will list me all of the records. If I wanted to see just the state records, I can filter it. So just having it here, and if I click, then obviously it shows the definition of the state record. But what if I wanted to ask a query whether a certain record with some field is updated at some point in the source code? So let's see this query, which is searching for the state record. Let me try to use this one. So searching for all state records, and that has a field loader queue, and I wanted to find the references for this state, but I just want to know that where this field updated. So I want to see that, because I have a problem that this field has a wrong value, so I wanted to see all of the places where this record field is updated. So then I can write a query like that, so filtering out only the record updates. So let me run this query. And then you can see that, for example, no, it was not the result of this. Yeah, it's the result. Sorry, just not the whole state record is highlighted, just the field. I will explain it to you soon. That's why. Okay, but this is a record, and the loader queue is updated. Why it's just the field which is updated? Because I have a so-called embedded query here, which means that the semantic query is working in a way that it always reflects to the last entity. So when the result of the semantic query is the last selector I've used, here is an expression. But if I use an embedded query, which means I'm putting the query, a subquery, into a squared bracket, then it means that the last element is the reference, so the field reference. So that's why the result of the query is the field reference and not the whole query at all. So if I'm removing this extra filtering here, then the result will be the whole record update expression. Okay, so now, but basically the result is the same, just what is highlighted is a bit different. Okay, so we may have some other references as well, just to show that all of them is referring to this certain record. Okay, so I have a few more minutes. So I wanted to show you the dependence graph as another point of my demo. So you can run, no, just one more point I wanted to show, sorry. When you are running queries, so let me just find one of my previous queries. So I'm filtering the openlog function. So you can type something here and run it, and then you will have the result. But in the browser, you can also have so-called built-in query in a pop-up menu. So if I'm just clicking on the function name, then I have a function references, so I can check. So it's a context menu. I can call the function references. If I'm clicking on the variable, then I have a variable-related context menu. And what I can do is that I can click, for example, variable origin, that will calculate me all the possible value that may flow to that variable. So, for example, if I click on one of these elements, then it shows me that this previous log may flow to the function call as an argument of the function call. It's really straightforward here because I have a variable. I assign that value to the variable, and then I'm calling the function with that variable. Okay, but we can calculate it interprocedural through different function calls and track the flow of data. So just to show a dependence graph, finally, as part of my demo. So what you can do is to calculate that which entity depends on each other. It has two levels, the module level and the function level. So you can calculate that if you have a module, what other module depends on it, or what what is the whole dependence graph of a software. This is what I have here. So you can just calculate as a module dependence graph. This is the module dependence graph of the Amnesia library. And if you, okay, it seems to be a mess. So there are lots of nodes and links in it. But if you click on some nodes, then it will be dynamically filtered, and then you will see just the relevant results. Okay, so you can see some red edges as well. It means that there is a cyclic dependency. Possibly A depends on B, B on C, and C on A. So there is a cyclic dependency between modules. If there's no cyclic dependency, you may use this result, for example, based on the passes, to define a load order of the modules or something like that. So this is a module dependence graph. I have function dependence graph. Let me try to show some of them. Yeah, I've updated the database, so it's warned me that it's probably out of date, so maybe the information is not accurate enough. This is just a filtered one, but you can see that you can filter it based on what's the starting module or the starting function. You can see that these are the connections only from the Amnesia and from the active checkpoint function. Okay, so, and you can see that there is a code duplicate step here. There is one result that highlights you different code duplicates. So you can play with it if you wanted to try. So just this is the functionality that basically tested and used as well, but this is just technical information, and I have a few slides about what I've showed to you. So now I want to jump on some experimental functionality that we are developing. For example, we try to analyze well-known applications or well-known structures from the Erlang OTP. So for example, lots of developers using generic servers to implement client-server applications or state machines, or of course supervision tree, also supervisors are often used. So what we are doing is that try to analyze these structures as well. So based on what I've mentioned at the beginning, that was we call it pre-analysis or a basic analysis, and then we try to build some post-analysis on that framework that is not done automatically when you load the code. It's just an initial analysis, and then you can run them as additionally. So, for example, you may have some supervisors implemented in your code, and then we can analyze and try to draw some graphs that what are these supervisors and what are the workers. And if you want, you can, so there are always a compact view that is just the basic structure, and there are some detailed view about it. We can generate kind of UML style state machines from the finite state machines. There are internal representations as well. This is just for UML fans, but we have other internal representations. this is related to generic servers. So if you have some gen server and you wanted to see that what are the messages that handled by gen server calls and cast, and what are the possible replies for that, then we can visualize it, and you can hopefully understand a code better. I think we have a detailed view based on the function clauses of the handle calls as well, because you can say that, okay, these are calls and cast, or separated by the different branches of the calls and casts. And one more thing that I wanted to mention as an experimental feature is the analysis of the beam files. RefactorErl now is working on source code level. So if you have a source code, then the source code, the Erlang files, the source of the Erlang files, then we can analyze it. But if you have only the beams, then we can't analyze it. So that's why we try to working on the compiler. And it's not released yet, so we are finalizing it, but basically we are able to handle most of the constructs from the Erlang code. So for example, for this simple, obviously the result won't be the same as the original code. So if we want to analyze it through the beam code, it's so this is the disassembled version of that ping function with lots of movs and register-based operations. And finally, we can get something like that, which is really ugly. We do not want to know anything about how it looks like. We just need the information. So for example, if we wanted to know what is a variable and how the values flows through the variables, then we can detect from this code. So we do not really care whether we have some extra variables. Data flow can just simply step forward on it. So we do not really want to recover the original code, just something that we have information in it. And my last slide is just to raise some attention that we are working much more. For example, we have functionality for pattern candidate discovery, which means that we are able to analyze, detect some sequential code part that reflects to a parallel behavior. So for example, that can be replaced with a parallel version of divide and conquer, or a map, a farm, a pipeline. So that well-known so-called algorithmic skeletons. So we identify some source code parts that reflect to that behavior, and we can assist in the parallelization. It's not fully automatic, so it's not so easy to do it automatically, but we can assist with refactorings in the parallelization process. And I think if you are interested, then you can check the homepage of the tool and check the functionalities as well. So that was my talk. So thank you for listening. I just have some screenshots, if the demo is not working. So it always happens. And I have a question and answer at the end. No, I do not have questions. So thank you for your attention.
Thank you, Melinda. Do we have any questions? I'll throw this to you. There's some drinks there, maybe.
Hi, thank you for your talk. At the moment, your university projects, do you plan to some form of startup and commercialize what you're doing?
Not really.
How are you going
so
to?
we do not really wanted to create a commercial project from it. So it's an open source project. Everybody who wants can contribute. So we are open. And if you wanted to add something, then you can. We do not really plan to do it. The university has a non-profit company, and if you need some special assistant, so for example, a kind of support or help in the installation or that kind of stuff, then this research and R&D institute may help. But we do not really want to commercialize it.
Another question? No? Okay. Well, thanks a lot, Melinda.
Thank you.
And now we'll listen to Johan Sommerfeld talking about Erlang meets Python.